This one more in computer number systems. So it says, what is the next hexadecimal number after A47 to have the substring 1010 appear in its binary representation? So I chose this one because it is kind of different than the previous ones, doing sort of addition, subtraction. We have to figure out sort of when 1010 appears somewhere in this binary representation after A47. So we should start by representing A47 as binary, right? So we'll start there. So again, we can represent A in 4 bits, which is 10, right? A is 10, so it's going to be 1010. In other words, that's no ones. There's a 2. There's no 4, but there is an 8. 1, 2, 4, 8, right? As the places. The digits represent those values. So there's an 8 and a 2. Okay, and then we have 4 represented with 4 bits. So that's going to be a 4. There's nothing else, so not so bad. That is 4. And then 7. 7 we know is going to be 1, 1, 1, a 4, 2, and a 1. And there's no 8 in there. So those are our values. So we should look. Do we actually have anywhere in here? Do we have 1, 0, 1, 0, 1 in here? Where we have 1, 0, 1, 0. Well, if this turns into a 1, that would be the next place. Or if we don't have a 1 here. So if we have 1, I'm trying to look at when the next place would be. And again, we might have to just start counting at this point, and sort of, and adding 1 to it every time and going from there. But I think we can sort of get to a point where we can logically maybe work this thing out. Like, we know that that this one is going to turn. Like, we keep an eye on these down here. I think I have a feeling that once this turns to 1, then we already have the 1, 0, 1 part of this, and then we can look at the 0, 1. That may be where we're looking. Again, we can keep on going. Again, I'm not really going to be changing this much, so I'll just look at these values for now. But if this ever changes to a 1 before, then I know that I have sort of that grouping, because again, I'm looking for this grouping in here. All right, so we can get to. I'm just thinking when our next value is, but again, we can go. We can just keep on going from here, right? So if I add 1, we know that it's going to be 1, 0, 0, 0, right? It's going to basically carry. And so we end up with this, right? And so we can count all the way up here, but knowing that even if there's no way in these 4 digits here that we're going to end up with, the pattern that we're looking for, because there's only 4, and we sort of start with 0, 1, 0, 0. So I can almost just skip a few of these and go all the way to like think about it. If I just go 1, 1, 1, 1, I can just skip a bunch of numbers in here, knowing that that's never going to be enough digits in there to get there. So like, yes, there were some in here, but I knew that it wasn't going to matter. Again, I'm sort of just working logically so I don't have to do every number out. Of course, you definitely can write every number after this if you wanted to, and then just find the pattern when it's there. Okay, so I'm thinking if I add 1 more, okay, if I add 1 more, that's going to carry, and this is going to turn into a 1, right? So it's going to be 0, 1, 0, and then it's going to be 0, 0, 0, 0. Okay, so now I already have 1, 0, 1, 0. So when this turns to 1, then my pattern is in there, right? So that's what I'm thinking. I can just sort of go and I could count from here, but I know again that if we have 1, 0, 1, 0, 1, does which one appears first? So now I probably would actually count the number. Just go ahead and just say, all right, we have a 0 right here, so that wouldn't be it. And then we have 1, 0. So does that meet the pattern? Nope, there's 2 1s in a row here. Wait, that was a 0. There's 1, 0. Nope, still there. So when I go ahead and I add 1 more, we get this. Add 1 more, we get 0, 1, 0, 0. And is that going to be it? Nope, we need to add, I think, 1 more here. So if we add 1 more, we get 0, 1, 0, 1, 0, 1. And then we can have 1, 0. And then, of course, we have these values here. Okay, so that is our full binary string. You can see that the pattern is actually right. Actually, we had it in this last one, didn't we? Yeah, because this actually, I wasn't writing it, but we did actually have it right here. Once this number turned to 1, which I think I set up here, but once this number turned to 1, it was right here. So wow, this is 1011. This is actually too far. This is one too far. We've gone too far. So we can take a look, and I can rewrite these as well. So this is our full thing here. So I'm just going to rewrite it as 1 0 1 0 0 1 0 1 0 1 0 0, and you can see that this, what we're looking for, appeared in it, which I'll do in blue because I did over here. Like the pattern is right here that we're looking for, which again was one earlier than changing this to a 1 and making it 1 0 1 0 1. So that it didn't appear at the end, which you might think it would have. It didn't appear to 1 before. So now it just becomes a matter of, it says what's the next hexadecimal number, so we need to turn this back to hex. So we check the groupings here. So again, if I, green is fine. If I group these here, I mean, they're already grouped actually. We know that this is already A because we didn't change it from before. This is a 4 and a 1, so that's just going to be 5. And that is just going to be a 4. So A, 5, 4. So those are our values. So A, 5, 4, of course, that's base 16 is our value there. Okay, awesome.